Hello, welcome back. I promised that I'll be coming with a interview series on data engineering. And here comes the very first video in the series. This is around deletion vector, a very important topic in Databricks, right? The hottest topic I would say. And I have covered 5 scenario-based questions related to that. I'm sure you would truly enjoy it. And if you enjoy, then of course you should make sure you like the video, comment on it telling how did you enjoy it, and also do subscribe to my channel. That will be a motivation part for me, right? With this, without any delays, let's get started. Let's say you are managing a very large delta table with billions of rows. So delta table in the sense it holds Parquet files and delta logs, right? You know that, right? Now it holds a lot of data. Now deleting just a subset of records, let's say 10 records, 20 records or 1000 records, right? Used to be very, very expensive because the system has to rewrite the entire file without those records, right? Then how does deletion vector optimize the process, or how does deletion vector makes the life simple, right? So we have to understand that. So let me first talk about the scenario when deletion vectors were disabled or were not there at all, or without deletion vector how things are. Let me explain you. Okay, so let's say we created a delta table, we inserted these 8 records, right? A file 1 Parquet file will be created, let's say file 1, whatever name, right? First file, and it will be like add file, and these are the records. Now let's say we fired another insert with some 8 new records, right? And a new file will be created and it will be in the metadata, right? In the delta logs, it will be add file 2, right? This is the, let's say file 2. Okay. Now let's say we are saying I want to delete a record which is record number 12, just one record. Then how the things used to happen earlier, right? So it used to recreate this entire file without this particular record. So it will have 9, 10, 11, 13, 14, 15, 16, but not 12, right? So you can see this new file will be created. I'm naming it as file 3. It can be any name, right? So it says add file 3, which is almost a full copy of this just without 12. And it says remove file 2. So you can see that if the challenge is that if this file has, let's say 1 million records and you are removing one record, you still have to write all the 1 million except that one record. That means it is very write intensive, right? Very costly to write, or whenever we delete a record, it becomes a very big burden for the write operations, right? And it leads to higher storage costs, even write times are more, and so on. So this leads to degradation in the performance, right? I hope you understood what is the issue when deletion vectors were not there, or by any chance if deletion vectors are disabled, right? And thankfully these days all the new workspaces comes with deletion vector enabled for your tables, right? So you really do not have to worry. Deletion vector make your life really, really simple. So with deletion vector, how things are these days, let's understand this. So let's say you have your file 1 with 8 records. Let's say you insert. Next again you are inserting 8 more records. It will say add file 2, another Parquet file. Now you are deleting 12. So now instead of recreating this entire file without 12, what it will do is it will just make an entry in the metadata, think it this way, saying that okay, so if logically you think, it will say remove file 2, that I do not want this file, and then it will say add file 2 with deletion vector. The only difference is, so if you do not consider this, then you think, oh, what we are doing, it's the same data then, right? How it's making a change. But the thing is, remove file 2, that means remove this, and then add the same file with deletion vector, which says kind of that, okay, this 12 has to be deleted, right? So kind of at the metadata level, we are making this change rather than data level. Data will still have 12, but while reading it, we read from delta logs, the metadata, and that will tell that, okay, you are reading this particular file, that's fine, but this file has a deletion vector associated, and that is on 12. So this entire file minus 12, that's what I have to read, right? And I will show you practically all of that. So in this case, there is no new file that is being created. Only a small deletion vector is created and the metadata is changed accordingly little bit so that it takes care of that. So now earlier we were making changes at the file level, creating new files. Now no new files are created. Only metadata is adjusted, indicating that, okay, this file, if we are reading this file, make sure we do not have to read the row number 12, right? I hope you can understand that. And with this, we are saving a lot of cost on the write, right? We are saving our storage cost, writes are faster, and so on. So let me show this practically. And once I show this demo to you, after that, all of the other questions that I have related to this will be very, very easy. So let me go back to my Azure portal. So this is my Azure Databricks account. I am in my free trial, right? And I would be using a serverless, very, very trending thing these days, right? Going forward, you would see serverless will be the go-to option for most of you. Now I have created a notebook, and by the way, a lot of changes have happened in Databricks. So whenever you created a Databricks workspace, right, you get a catalog with the name of your workspace. So this is my catalog name, right? So if I just show you that, so if I go to my workspace, if you can just see, I'll show you here, right? So you can see this name, that is same as my workspace name. So whenever you create a basically Databricks workspace, it is associated with the meta store, and you get a catalog with the name of the workspace. And that's what we have right now. So we have training _ Central India. Central India is the region where I have created this workspace. Okay. And inside this, by default, there is this default schema or database, whatever you say, right? And now we can create tables, volumes inside this, whatever we want. I hope this is clear. Now, I have connected to serverless. It takes hardly a few seconds to do that, right? Instead of classic compute. And this works really, really well. And it is recommended by Databricks. Now, first thing that I would want to do. So you would know that DBFS is kind of not that much used or deprecated because it does not provide you security in terms of the content. So that's where volumes is recommended these days. And we would be using volumes for this demo. And it's a very simple demo, right? Now I'm saying create volume. If not exist, my demo volume. So in which catalog, in which schema it will create. So by default, we are connected to our default catalog, which is with the name of workspace name, right? And inside this, we have default schema. So it will go inside this now. So right now, if I refresh, you see inside default, there is nothing. Inside default, there is nothing. But now I am saying I want to create a volume with this name, my demo volume. Where it will be created? Inside this default. Let me quickly show you that. I am running this command, and if there is no volume, it will create now. And I will refresh this, and you see my demo volume. Okay. Now inside this my demo volume, let me create a folder. Let me create a directory inside this. And let me give a name to this. Let me see what I have used in my demo. DV demo, right? So that's the name I will give. DV. Why I gave this name? DV understanding deletion vector, right? Demo. That's the folder I am creating here. Okay. Now we will be using this. We will be using this. So now what I will do is I want to create a Spark data frame, right? So very simple stuff. I really do not want to go deep because my objective is to explain you deletion vectors. So you see I am creating a very small data frame with 3 records, right? And with just 2 columns as schema. So let me create this data frame. And you can see this is the data frame, ID and name. Now I want to write this data inside this folder in Delta format, right? How do I do this? So I define my volume path. Volume path I get from here, this entire path, right? Now I took this volume path and I say df.write, whatever data frame I have created, I want to write it in Delta format. By default format is Delta anyways. Mode overwrite and save it in this location. So let me run this. Let me run this. And now if I refresh basically, you can see I get one Parquet file. I got one Parquet file. This is a Parquet file that I have, right? You can see this, and Delta log and Delta log. You can ignore .crc inside this, and .json is what is important, right? So it would be some Parquet files which will have the data, and in JSON it would say, okay, I want to add this particular file name. I will show you that. Soon I will show you that. Now we can query this without creating a table. There is a way that we can just say delta dot and this proper path, if we give inside double ticks, it will treat it as if this is a delta table, right? And without creating a table itself, we can use it quickly. So for quick demos and all, this is very handy. So I am just doing a select star. Okay, I got 3 records, that's perfect. Now I am inserting 3 more records. So I am creating a data frame with 3 more records, and I would insert it, and this time rather than overwrite, I am appending it. I hope this should make sense. So now it should show me 6 records. 6 records it should show me. And if I go here and refresh this, I should see one more Parquet file and one more JSON file. So you see we got one.json newly, right? And if I go to this, I see 2 Parquet files, right? This is the one which is recently created. And if I show you this snappy.parquet, that's fine. Okay. Now I want to read the content of Delta log, right? I want to read the content. That means I want to read the content of this JSON. I hope this is clear. Here you won't be able to see it properly. So what I can do it in my notebook. I can give the full path. Let's say I am saying 00.json, right? I am giving the JSON path spark.read.json, and I want to display. And you can see this shows add, right? And it will say add the very first file which I had. The very first file. So if I go to files, files, right? The very first file is the older one, right? And the name of it, you can see ec dot, right? ec dot, and we can see this. It will say ec dot, right? So this is the file. It says add this. It will say add this, and it has put some statistics related to that. That's fine. But you can see we have added this file, saying that it has to be added, right? Because when we are reading it, first it checks this, right? Based on this delta logs only, it gives you the output. So it will say add this file. That means this file has to be shown, kind of. Think it this way, right? Now let's say, and if I basically show you here one.json, it will show add the other file. It will show add other file. So you can see this, right? 41.c, this one, the other one. So I'm sure you are clear with this. We have commit information and all, that's fine. But add is the important column which you should understand. Now let me delete a record. I'm saying delete from, as I said, consider this as a table where id equal to 4. I'm deleting one of the record from file 2, right, from file 2. And it says number of records affected 1. And let me see the history now. Let me see the history. Describe history, table name. So what it has done, the very first thing we have written, you see write, right? We have write, which is in overwrite mode, right? First 3 records. Then we have again written append mode. You can see more details here, right? You can see all the details. Now after that we perform a delete operation. And after that optimize, it has done automatically. Let's not worry, but write, delete, right? And if you see this, you can check more details related to this. So here if you see operation, number of files 1, right? Here number of files again 1, you can check this. And number of files removed 0, number of files added, number of deletion vectors added 1. So I'll talk more about it, right? Right now, once I show you, it will be clear. Now, what I want to show you is that if I do a select star anyways, if I do a select star, if I go up and do a select star, it will show me 5 records. It will show me 5 records, right? But the important thing that it will have done internally is it would have, so we earlier had 1, 2, 3, right, in the file 1, right? So it says add file 1, right? We have 4, 5, 6. It said add file 2. Now we said delete record 4. That's what we have mentioned. We have said delete record 4. Now what it would do as per the logic, because deletion vector is enabled, what it will do? It will say remove file 2, right? Add file 2 with deletion vector. And for deletion vector, there is a very small file, bin.bin file, which is created along with parquets, right? Two parquets were already there for this, right? For this deletion vector, a new .bin file will be created along with the parquets, right? And then in the metadata, what it will say? Remove file 2, add file 2 with the deletion vector. And I will show you that. So if I just go to this files and refresh, 2 files were already there. If you can recall, 2 files were there, ec.c0041, these 2 were there. Ignore this file for now, ignore this file, but you see this is the file, deletion vector file, very small file which it has created .bin file, right? It's not that it has copied entire data, no, it's just having an indication that okay, this particular record has to be deleted, kind of, right? And then in delta log, we have 0.json when we edit first 3 records, 1.json when we edit the next 3 records. Now it has created 2.json. And why 3.json I will tell separately. That's a different thing, right? It's part of internal optimization. So 2.json is important, and let me show you what is the content inside this, right? So if I go here and I say 2.json, this will give you a complete clarity on what has happened, right? And how you have to read it is row by row. First row if you have to read. So if you go right, you see there is something called as remove, right? So first row first and second row second. That's how you have to read. So you can see first row, nothing, no add, no remove. That's fine. But now second row, there is no add but a remove. What it's saying? What it is saying? We want to remove this particular file, c000.snappy.parquet. That was the second file we had, right? Second file, this one, where the record 456 was present, right? You can see it is saying remove this file. Okay, so you remember 41 here, right? Now if I go to the third row, then after that what it will do? It will say add the same file because it's under add, you see, but with deletion vectors. If you see deletion vector, right, you can see deletion vector here coming into play. That's the important part. So in the metadata, it has adjusted or made changes. So when reading it, when we are doing a select, it will kind of read this file, but along with deletion vector, so that while showing you, it will remove that record, right? That record is still present on the disk, but while showing you, it will not show you, right? And that's the beauty of deletion vector. Now, you might say that, okay, why was there another Parquet file along with this, right? If you can recall, there was another Parquet file. This we never thought should be created, this Parquet file, right? This is as part of internal optimization, where what it has done, it ran optimize command. So this was the history command that we ran, and you see write, delete, and internally it has done optimize. Optimize is when it finds there are small files, it combine it into one, right? So what it has done now is it has removed all the files, right? It has removed all the files and it has created one single file, merging the data, because otherwise we might lead into small file problem. That's what optimize command, and internally it has run it automatically, right? So if you see here, if you see what it would say, it has removed two files. That means it has removed both the Parquet files, right? And it has removed one of the deletion vector also. That means all three files, two Parquet files, one deletion vector file, it has removed, and it has just created one file clubbing all of this, so that when we do select, we just need to read that file. And that's it has done as part of internal optimization, considering that if we have all the data in small files, it might be tricky to read, right? And if I show you here 4.json, right? If I show you 4.json, you would see that I am in 3.json. That's the last JSON file, right? So it would have removed the things, and then it has created one more file. So you can see this remove. So it has removed the very first file, right? Okay. It has removed then the second file also. Along with deletion vector, it has removed. You see this file along with deletion vector. And then if I go down, you see it has created one additional file clubbing all of this, right? So that someone, when they are querying the table, it just scans this particular file, nothing else. I hope this makes sense. So this would have given you a lot of clarity. Now let me run describe detail command, describe detail table name. And you can see what it gives me. You can check delta enable deletion vectors true. And if I see the statistics, how many number of rows deleted by deletion vector 0, number of deletion vector 0. That means there are no deletion vectors in this table version that we have. Last table version, there are no deletion vectors because optimize command ran and we got a single file, right? So that's the thing. That's why you do not see any deletion vectors. So sometimes this is the place from where you can see how many deletion vectors are there and all of that, right? Now, what if you want to, so you remember that we are at which version now? We are at which version? We are at version 3, which system gave automatically as part of optimize. What if we went to version 2? Then we can understand things little better, that there should be one deletion vector there, right? So I want to go to version 2. That is, I want to do time travel. This is called time travel. So I can say restore table name to version as of 2, right? So I am going to a previous version before optimize. This is running and you can see the results. You can see the results for this. Okay, that's fine. Now I want to say describe detail. I want to get details of the table now, because now we have restored it to a previous version, right? Before the optimize. Now I want to see. And if I check here, if I check here statistics, it will show number of deletion vectors 1. So this is the place where we can see the number of deletion vectors, that are number of deletion, lot of deletion vectors are accumulated or what, right? So we can see that. Now again we can go to the latest version, right? Let's go back to the latest version. I think this percentage command, from where it came, I do not know. Okay, I removed that. I am going to the latest version, which is the version 3. Okay, fine. Now with this I'll show you other commands, but now we are in a very good frame where we can solve a lot of things, right? So the question was, you are managing a large delta table with billions of rows. Deleting even a few thousands or very small number of records, it was very expensive. How does deletion vector solving it? Deletion vector is solving it by making sure we are not rewriting the entire files. Rather, it's just adding a very small file for the deletion vector, and in metadata it is making appropriate changes, right? So that things are taken care of. So we are not rewriting the data now, basically. Right? So it will save you storage cost, it will save you time for your writes and so on. Okay, so this is the thing. Now you understood this. Let's go to the question number 2. Now imagine two cases: deleting 100 records, deleting 100 million records. In which case do deletion vector bring the most benefit, and when would you consider a file rewrite instead? So basically, if number of deleted records are less, then only it makes sense, right? Because in a file with 1 billion records, if we are just removing one record, right? If we are removing one record, then we are just adding details related to that one record. But kind of, let's say, if we have a file with 200 million records and we are deleting 100 million records out of it, half of the data, then it makes sense to do rewriting only, because then there will be so many deletion vectors. The time to kind of read the data, right? Because when reading, it kind of checks or filters the deletion records and it shows you the data. It will take a lot of time, right? So kind of when we are deleting less number of records, then deletion vector plays a very crucial role or can help you a lot. But when you are deleting a lot of data, when your application is delete intensive, then of course a file rewrite would have been a better option, and you can turn it on or off at a table level using this property, delta.enable deletion vector table property, right? So I hope you kind of understood. It's a very logical thing. Okay, fine. Now consider your company, right, must comply with GDPR requirement. That means right to forget, right? That means some data has to be deleted from your systems permanently, right? Now since deletion vector, so as you know, deletion vector, the data is still residing on the disk. It's just that it's a logical or a soft delete, because we are putting a tombstone marker kind of thing, and just while reading it understand that okay, we have to not read this or we have to ignore this while showing the results, right? So since deletion vector only mark rows as deleted, the data still exists in storage. How would you design a process to ensure deleted records are physically removed for compliance? Because you have a compliance to follow, you want to physically remove those records. How will you go about it, right? So basically here you have to understand that you can always run reorg table, right? And the table name apply purge command. So reorg table command, this will rewrite files and merge the deleted records. That means kind of it will get rid of the tombstone markers or the this thing, deletion vectors, right? So it will rewrite the data in a way that deletion vectors are taken care. Kind of you do not have to then read the deletion vectors, right? Without deletion vectors, you will be able to read the proper data. So it will do the heavy lifting now and it will rewrite the files, right? So if I show you a command something like this, reorg table, table name, apply purge. In our case, it won't do anything. In our case, it won't do anything because the optimize command ran and we just have one file. But this is the command which you could have run, right? You can see this. And after this, generally, it will be as part of your maintenance process. If you are having deletion vectors, then as part of your maintenance process, what you might be doing, you might be performing this command. After that, you might run optimize command. Why? Because optimize will kind of merge small files into bigger files to avoid small files problem, right? And then after optimize, you might run a vacuum command so that whatever Parquet files are not in use, those will be deleted from your system, right? Those will be permanently deleted from your system. I hope you know that. By default, there is a retention of 7 days. That means when we do a vacuum, it will remove all files older than 7 days which are not in use, right? But we have to be very careful when running vacuum because it limits our ability to go back in time travel, right? So if we want to do a time travel for longer period, then of course we have to be careful in doing vacuum, right? So a series of 3 commands: reorg table, so that it merges deletion vectors, so that deletion vectors we are not dependent on them, right? Then optimize to take some small files and create bigger files, and then running the vacuum command so that we get rid of the data which is not in use, right? I hope this is clear. So this would ensure that the deleted customer data is not just hidden logically, but physically it will be removed from your disk, satisfying the compliance requirements. I hope this is clear. Okay. Now, next question which the interviewer can ask. Like over time, analysts complain that queries on Delta table are becoming slower and slower, right? After frequent deletes, the queries are becoming slower and slower. How would you confirm whether deletion vectors are the cause and what steps you can take to restore performance? So now, if you perform a lot of deletes, there will be a lot of deletion vectors created, and while reading, it reads the file and then it has to check the deletion vector and ignore that data. That means it has to do filtering that time, and it will take time for your read. So if deletion vectors accumulate, your reads can go slower. That can be an issue, right? And how do you know how many deletion vectors are accumulated? You can run the describe detail or describe history. I have shown you when you do a describe detail on the table, it shows you how many deletion vectors are there, right? I have shown you that. So if there are a lot of deletion vectors, then you have to probably run this particular command. You have to run reorg table command so that the files are rewritten and we get rid of deletion vectors, right? And then you can after that run optimize and vacuum accordingly. But if you kind of run this reorg table and optimize, it will solve the purpose, right? So in my reference notes, what I'm saying, inspect the table metadata using describe detail or describe history to check for a high count of deletion vectors. And if the count is high, then what you can do, you can basically make sure that you reorganize your table in a way that deletion vectors are taken care or merged, right? And how you do that? With this command which I have shown you. I hope this is clear. So if deletion vectors are the bottleneck, the fix is to periodically compact and apply those deletions physically. How to do that? Using reorg table command. And in Databricks, that means running the reorg table, this rewrite the files, and periodic optimize commands will help additionally, right? Okay, fine. By the way, I want to just give you an idea that when this optimize runs automatically or when you run optimize, there is no guarantee that this deletion vectors are taken care and merged inside that. There is no guarantee, right? So if really you want to take care of deletion vectors, right, 100%, then you have to run reorg table command for that. Okay, but a lot of deletion vectors floating around can definitely significantly impact your read performance. You have to know that. Okay, now the last question here. After months of deletes and updates, you notice storage costs have gone up, right? And the queries are becoming slower and slower, right? The storage cost is also going up. That's crazy, right? Because why do we enable deletion vector? To make sure storage cost goes less. But now with deletes and updates, your storage cost is going high and queries are becoming slower. Even though deletion vector were meant to save space and time, why does this happen? And what Databricks operations you apply to balance storage, performance, and compliance? Right? See, this would happen because deletion vectors are logical deletes, right? It's not deleting the data. Data is still kept there. And they reduce rewrite cost. So we understand that it does not have to rewrite full new file because we are just putting deletion vector and adjusting the metadata. But over time, the table accumulates a lot of dead weight. That means whatever data is deleted, we are still holding that, right? And the metadata is increasing considerably. You think that way, right? So let's say in a table with 200 million record, you have deleted 100 million, right? Then half of the data you have deleted. That means you are managing all of that metadata. Your reads will become significantly slower, and even storage it will take to hold all of that metadata and deletion vectors, right? So you can understand that's the bottleneck. So queries must scan files full of deleted rows, because when you are reading, you also scan deleted rows and then you ignore those rows. So it takes time and it takes storage also, right? So it can be good when there are a lot of records in a file, but you are deleting some records. But when you are deleting too many, then you have to do reorg of the table in order to make sure things are balanced, right? And to fix it, again, run reorg table, optimize, and then vacuum. So this reorg table will make sure deletion vectors are embedded and new files are created. Optimize will make sure smaller files are combined into one bigger files so that the performance is improved. And vacuum will ensure that files which are not referenced and older than a certain limit will be cleaned up from your system, will be removed from the disk. In both of this, there is no deletion of files. The files will still be present, but vacuum will remove the unused files beyond a certain duration, right? And let me show you that. So let me run the vacuum command, right? So if I say vacuum table name, right, retain 0 hours. See, by default retention is 7 days, and in our case none of my file is older than 7 days, so nothing will happen. I want that any file which is not referenced now, right, please remove it. Do not worry how old it is. Even if it was created recently, delete it, right? So if I run this, it will give me an error, right? Oh, such a low retention period, we might corrupt the things and all, it's saying, right? That's what it's saying. And it would say you can turn some this thing property spark.databricks delta retention duration check enabled equal to false in order to do that, right? By default, we cannot go less than 168 hours, which is 7 days actually. That's what it's saying. So let me just close it and let me try setting it up. Let me try setting this variable and this will give me an error. Now, if you would have run this on a classic compute, this will work. On serverless, it will give you an error because in serverless, there are some limitations of these kinds. Because in serverless, we do not have much control around this environmental things. Because they are already giving a high performant environment. So they do not expect us to change these things, and that's fine, right? So a roundabout way to do this is we can alter the table, alter table name, set table properties, and this we can mention as 0 hours, right? Retention 0 hours. And now if we run vacuum table name, right, it should work, right? And by default, if any of the file is not in use, it will remove it. But it's always a good practice to do dry run. Dry run means it will tell us that if I run vacuum command now, which files it's going to remove. Let's see. and it should remove all the files which are not in use, because optimize created a new file. So you can see. So you can see this. It is removing the deletion vector and the two Parquet files. And the fourth file which we have through optimize, that only will remain. Other files it's saying that if you run vacuum, it will be deleted because the current table version does not refer that, right? So let me do vacuum table name and it will remove this. See, make sure you have to be very careful when running vacuum, because it's not a good practice to run vacuum right with less than 7 days period, because then it limits, we cannot go back in time. It will we cannot go or do time travel, right? If we want to go to a previous version, how will we go now? Because there is no files present. But you can see anyways that this has run, and if I go here, you can see only one Parquet file, only one Parquet file, right? And this is it. So you kind of understood the role of deletion vectors, the challenges of deletion vector. So in a nutshell, deletion vector kind of, it improves the, whenever deleting, so we have to do considerably less write or no write, right? Otherwise, previously we have to take the full file and make a copy of it. Now that does not happen. So it saves your storage and the writes are faster that way, right? Plus, now in case of your reads become slower if there are a lot of deletion vector, because it has to even read the deleted records and then filter those out, right? So that's the thing. And now if it keeps accumulating, then it's a challenge. So make sure you have to run reorg table in order to fix it. Plus, when we have GDPR compliance or when we have to delete the data from our system, we have to make sure, because deletion vector is a logical delete, the data is still capped. So we have to run reorg table, then optimize, and then vacuum in order to get things done, right? So this is how we can think about it. And it's a very, very important topic. And I have tried to cover all the scenarios related to this in a way that you should understand it fully, right? And now, if you have not subscribed to my channel, what are you waiting for? Do subscribe. And if you truly like this video, right? If you truly like this video, then make sure to like, comment, and then that will be a very good encouragement for me, right? And I will try to come up with more scenario based questions in my upcoming videos. By the way, this was around Databricks Delta Lake and the most important topic, deletion vector, which is a fairly new thing in Databricks. Many people would not be even fully aware of it, right? Very, very important interview questions, and make sure you prepare it well. Thanks a lot.